सर्व विद्यार्थ्यांना परत एकदा हार्दिक वेलकम. Now in this today's lecture we shall discuss the equation for the kinetic energy. Actually you know the equation for the kinetic energy when a particle is moving with velocity v bar. Now are you hear me? Okay, आवाज येतो का? Now see here, actually in the last lecture we have seen that the kinetic energy means the capacity of doing the work is called as a energy. Also we have seen the comparative study of the power. You know what is mean by power? Power means the time rate of change of doing the work, that is a power. And capacity, time rate and capacity, this is the difference between power and energy. Energy means the capacity of the doing the work is called as a energy. Actually there are two types of energies. First type is called as a kinetic energy and second type is called as a potential energy. See this this is the here potential energy. Actually potential energy and kinetic energy, these are the two types of energies. Now today we shall prove the most important relation and one important theorem, that is prove that the equation. See this theorem among the kinetic energy. Theorem, 1 minute आता जरा सेटिंग लावतो. Theorem, what is the theorem? To prove that the kinetic energy of a particle of mass m and moving with velocity v bar is 1/2 mv bar square. Okay, Harshada Joshi, correct. Now we have to prove this relation, that is a kinetic energy of the particle having a mass m and moving with the velocity v bar is 1/2 mv square. Actually this is a very simple theorem, but it is very important theorem, you have to know. So proof. See this, suppose a particle is moving from a point A to the point B along the curve. See this, due to the force F bar, the particle is moving along the curve P. The mass of a particle is, suppose at any instant of a time t, the position of a particle is at a point P, the mass of that particle is small m. Okay, small m be the mass of a particle. Then we have to prove that the kinetic energy of a particle is 1/2 mv square. This is our aim, or this is our main result. Okay, now you know that. Students, now you tell me, what is the definition of energy which we have studied? Actually we know that the kinetic energy, let consider a particle, of a mass m and moving with velocity v, let F bar be the force acting on the particle. F bar be the force acting on the particle. of the particle F bar be the force acting on a particle. See this. We know that kinetic energy is equal to the amount of work done by the external force. We know that the kinetic energy we know that yesterday we have seen energy means the capacity only. See this, energy means the capacity of a particle doing the work, but kinetic energy means we know that the kinetic energy of a particle is equal to the kinetic energy. We know that the kinetic energy is equal to the kinetic energy is equal to the amount of work done by the external force. Amount of work done by the external force required to give that velocity required to give it that velocity starting from at rest in time t. See this, consider a particle is moving with velocity moving with the velocity v bar. Let this velocity is obtained due to the force F bar which is acting on a particle. We know that the kinetic energy is equal to the amount of work done by the external force required to give it that velocity starting from at rest in time t. See this is a particle. If we add some force on that particle, then it particle moves with the velocity v bar. At the initially its velocity is 0 due to the action of the force. It goes to the velocity by the velocity v bar from time t is equals to 0 to t. Okay, at the time t its velocity is given by v. This is note that at the time t its velocity is given by v in time t particle. So full stop. Let the particle move in this time t from point A to the point B. See this, note here the velocity at a point is 0. See this, where the velocity at point A is 0 and velocity at point B is, suppose VB, velocity at point B is VB, which is denoted by V bar. See this, again I shall explain this concept. We have to find out the equation for kinetic energy. That means we have to prove equation for the kinetic energy. See this, suppose initially the particle is at rest, the mass of particle is m. If a force F bar is acting on that particle, then particle goes in the displacement. The velocity of that particle is suppose v bar. At the initial stage, at the point A, velocity is suppose 0. At the point B, suppose there is a point B, the velocity of that particle is suppose Vb, which is denoted by v square. But displacement from point A to point B require a time t. Initially time t is equals to 0, but at a point B, to move from A to B, particle requires time small t. See, this is the concept which we have to know. Now, so we have to find the kinetic energy. Therefore, we have the kinetic energy means amount of work done in moving a particle from A. So we can write kinetic energy which is equals to amount of work done in moving particle from point A to the point B, from A to point B along a curve due to the force F bar. Due to the force F bar. So we can write this in the form of an equation. So kinetic energy which is equals to, we know that we can measure the kinetic energy or energy in terms of integration, because work done due to the small displacement. What is the formula for the work done? Rushikesh Serekar. Now you tell me formula for the work done. Work done means force into displacement. Suppose delta r bar be the displacement, force is the F bar. So work done means force into displacement. But we have to find out the total work done from which particle moves from point A to point B. So we have to take the integration. We have seen in the theory of work done, in the day before yesterday, we have seen how to find out the work done of a particle. Work done means it gives the integration from A to B. So kinetic energy means the total work done, amount of work done when a particle moves from point A to the point B. So it is given by the relation kinetic energy is equals to integral from A to B F bar dot dr bar, force into displacement. Already we have seen this. Now we can write integral from A to B F bar dot, we can write the chain rule, F bar dot dr bar. Dr bar means, okay, we shall write this. But we know that how we can define the force. Force म्हणजे काय सांगा बरे. Force means the product of mass into acceleration. So we can write m into A bar into dr bar, which is given by, so we can write this as a, since F bar is equals to ma bar. You know that we have seen according to the Newton's second law, we have proved this relation. So kinetic energy is equals to integral from A to B m into A bar into dr. Again we have to use here chain rule. Dr can be written in terms of dt divided by dt multiply by dt by the chain rule. Okay, so F bar means mass into acceleration. So M into A bar. Very good. Krishna Dokade, Falak Patan, Sakshi Kadam, answer de Krishna Ale, Mayuri Gogde. Okay, we can write this. Again, here is a dr, so we can convert this dr into dr upon dt into dt. Now also you know that for acceleration means the rate of change of velocity. You know students what is mean by the relation for acceleration. थांबा मी थोडे स्क्रीनशॉट घेतो, कोण कोण आन्सर सांगतात त्यांच्या स्क्रीनशॉट घेतो. हा, now you tell me the acceleration. What is the acceleration students? Now you tell me. कारण मुलं जे आहेत ना आपल्याकडे 100 मुलं आहेत, यांना परीक्षेला नाही बसू दिलं त्यावेळेस तुम्हाला महत्त्व समजेल, असंच नाही समजणार आता. So we shall discuss what is mean by the acceleration here. Acceleration means rate of change of velocity. Very good, Pranit Mule. That means we can write integral from A to B. M as it is. Acceleration means dv bar by dt into dr upon dt into dt. See this, you know that. See, we can write here acceleration A bar is equals to dv bar by dt. Okay, now we know that integral from A to B, m into dr bar by dt means v bar, dv bar by dt as it is into v bar into again dt as it is. See this, we can write the, because we can write dr bar by dt means v bar. Rate of change of displacement, you know that rate of change of displacement means velocity, velocity means dr bar by dt. So we get the relation integral from A to B, m as it is v bar into dv bar by dt. It is also written as a dt. Okay, now v bar into dv bar by dt is, you know that, see here, I shall write here, you must know the concept regarding v bar into dv bar. Suppose there is a vector v square, हमारे पास v square है, अगर v square का डेरिवेटिव निकालना है स्टूडेंट्स, now you tell me what is the derivative of v square with respect to t. Now you have to find the derivative of v square with respect to t. चलो रे स्टूडेंट्स, now you tell me what is the derivative of v square with respect to t. v square चा derivative with respect to t काय आहे तो सांगा रे. हा, कोण सांगेल? चला सांगायचं, मुलं सर्वच प्रेझेंट पाहिजेत. मी परत एकदा सूचना द्यायला लागलोय तुम्हाला. 6व्या सेमिस्टरचं मी हॉल तिकीट नाही देणार, सर्व विद्यार्थ्यांना सूचना द्या. हॉल तिकीट काही केलं तर माझ्याकडे यावं लागतं. लेक्चर सर्वांनी करणं गरजेचं आहे. मी तुमच्या अडचणी ओळखू शकतो, तुम्हाला काय असेल नसेल, पण ऑनलाईन लेक्चर करायला काय अडचण नाही, सर्वांनी लेक्चर केलंच पाहिजे. हा, व्हेरी गुड रुपाली धाबेकर, व्हेरी नाइस. v स्क्वेअर, डेरिवेटिव ऑफ v स्क्वेअर मीन्स v स्क्वेअर का डेरिवेटिव होता है 2v into dv bar by dt. Very nice. So v into dv can be replaced by, see this, v into dv can be replaced by 2v into dv can be replaced by derivative of v square v dv means, so integration of integral from A to B, m as it is v into dv can be written as 2v bar into dv bar. Okay, v into dv by dt can be written as v square d by dt of, हा परंतु इथं 2 नाही आहे. 2 नसल्यामुळे आपल्याला ॲडजस्ट करावं लागेल. एक मिनिट, 2 नसल्यामुळे ॲडजस्ट करावं लागेल. वी शॅल ॲडजस्ट दिस फर्स्ट. ओके, See this, V into dV. V into dV we can written as, how we can write, 1 by 2. So we can write this as यहाँ पे 1 by 2 into, see this, so we can write 1 by 2 into d by dt of v bar square into dt. See this, v into dv can be written as 1 by 2 into d by dt of v bar square. So 1 by 2 and m both are the constant quantities, so we can write 1 by 2 which is a constant, m is also constant, then integration becomes integral from a to b d by dt of v bar square into dt. Now see this, integration and derivative are inverse of each other. The process of integration and process of derivative are inverse each other. So we can write, we can remove this integration and derivative, this derivative and this integration which are the inverse of each other. So we can remove this integration with respect to t and derivative with respect to t. See this, integration with respect to t and derivative with respect to t both are the inverse process of each other. So we can remove this and then we get 1 by 2 into m, this is v bar square. So upper limit and lower limit is as it is. Now put the upper limit. See, this is a kinetic energy. 1 by 2 into m as it is. Upper limit means vb square minus va square. That means 1 by 2 m into velocity at a point B minus velocity at a point A. Now you tell me, velocity at a point A, which is the quantity which gives the velocity at a point A? Velocity at A. Vb square means velocity at a point B, its square, minus velocity at a point A, its square. Va square and Vb square का मतलब ये होता है, so 1 by 2 m into velocity at a point B which is given by V. See this, velocity at a point B, Vb, which is given as V. So V square minus velocity at a point A. What is the velocity at a point A? Which is a 0. Very good, Harshada Joshi, very nice. So we can write this is a kinetic energy is equals to 1 by 2 mv square. You know that v bar square means, suppose a bar dot a bar, which can be written as a bar square and that can be also written as a square. किसी भी अगर वेक्टर का हम स्क्वायर लेते हैं तो उसके मैग्नीट्यूड का स्क्वायर होता है, वहां पे वेक्टर लिखने की जरूरत नहीं है, बार लिखने की जरूरत नहीं है. सो दिस इज द एक्सप्रेशन फॉर द काइनेटिक एनर्जी एंड हेंस प्रूव्ड. हेंस प्रूव्ड. डू यू अंडरस्टैंड दिस? ये देखो इस तरह से ये इक्वेशन होता है. नाउ वी हैव टू प्रूव दिस. वाटलं तर इथं हे न लिहिता इथं लिहिलं तरी चालतं. ही टर्निंग स्टेप आहे, तुम्हाला समजली पाहिजे. So we can write there V into dV. V into dV means we can write this as 2V dV by dt. इसका मतलब होता है 1 by 2 V bar square. 1 by 2 V bar square. 2 या साईडला येतो किंवा 1 V bar square चा जर तुम्ही डेरिव्हेटिव्ह विथ रिस्पेक्ट टू t घेतलात तर v बार इंटू डी व्ही बार बाय डी टी येतो. 2 येतो, 2 2 कॅन्सल होतं. मीन्स इनिशियल व्हेलॉसिटी, इनिशियल टर्म इज ॲज इट इज. इनिशियल टर्म इज ॲज इट इज. सो देर इज नो चेंज. So you must know what is mean by the velocity of a particle. You must know Actually, velocity of a particle is v bar, and v into dv bar by dt means it is equivalent to the 1 by 2 d by dt of v bar square. So you must know all these things. समजलं का रे हे रिलेशन सर्वांना? समजलं का स्टुडंट्स? हे लक्षात आलं का रे? आन्सर काही कुठं अडचण आहे का विचारा. इफ यू हॅव एनी डाऊट then you can ask. Only this is a important turning step. This is a important dr bar by dt means v bar into dv bar by dt. It is a meaning that 1 by 2 into d by dt of v bar square, 1 by 2 into d by dt of v bar. हे रिलेशन एक टर्म एवढी जर तुम्हाला व्यवस्थित समजली, एक टर्म जर ही जर स्टेप समजली तर बाकी सर्व खूप इजी आहे, काही अडचण नाही. थेरम खूप महत्वाचा आहे. यू मस्ट नो ऑल दिस थिंग्स. ओके, नाउ वी शैल गो मूव टुवर्ड्स नेक्स्ट थेरम, थेरम नंबर 2, और इट इज कॉल्ड एज अ corollary. Or it is also called as a corollary of a first theorem. Corollary of first theorem. What is that statement of the corollary? Prove that the change in kinetic energy of a particle, change in kinetic energy of the particle is equal to work done. Change in kinetic energy is equals to the work done, which we have to prove. Same, we know that the velocity of a particle at a point is v. Now suppose that particle is moving with a velocity v bar due to some variable force f bar. Suppose that velocity of a particle at a point, suppose this is a point A, this is a point B. Now suppose that velocity of a particle at a point A is denoted by VA bar, which is not equals to 0. Then velocity of a particle at a point B is denoted by VB bar, which is also not equals to 0. अभी देखो पहले थ्योरम में यहाँ पे इन दिस थ्योरम वी हैव कंसीडर दैट द स्टार्टिंग ऑफ मोशन ऑफ अ पार्टिकल इज फ्रॉम पॉइंट ए. सो एट अ पॉइंट ए its velocity is 0, but suppose that particle is continuously moving, particle is continuously in the motion. Suppose that particle is continuous in the motion. At any instant of a time t, the velocity of a position of a particle is at a point A. Its velocity is denoted by VA bar. After some time t, the position of a particle is at a point B. Its velocity at a point B are VB bar. Velocity at a point A is VA bar. Note that VA bar is not equals to 0 because it is not a starting point. VA is not a starting point of the motion of a particle, suppose. So we can write this. Consider the particle of a mass m, moving with the velocity moving with the velocity v bar due to the variable force F bar. See this, due to the force F bar. See this, let the velocity of a particle at a point A, let the velocity of a particle at A is VA bar and not 0, which is not 0. Also, the velocity of a particle at point B is what is that? Velocity at a point B is VB bar. Now we know that. We have proved the relation. What we have proved? The kinetic energy of a particle is equals to 1 by 2 m into velocity at a point B minus velocity at a point A, where A and B are any 2 points. So we can write the kinetic energy. See here, we can write this. We have proved that to find out the work done. See this, the second theorem, that is a corollary. Prove that the change in kinetic energy of the particle, is equal to the work done. Change in kinetic energy of the particle is equals to the work done. Consider a particle is moving along the curve due to the variable force F bar. At any instant of a time t, the position of a particle is at a point A. After some time t plus delta t, the position of a particle is at a point B. Suppose that the velocity of a particle at a point A is VA bar, velocity of a particle at a point B is VB bar. Both velocities are not equals to 0 because VA is not a starting velocity. Now, so both velocities VA and VB are not 0. These are the due to the force F bar, m with the mass of a particle. So see this, we have the work done moving a particle from a point A to B, or total work done. You know that according to this relations here, kinetic energy means amount of work done moving from the particle A to B. See this, amount of work done means kinetic energy. So we can write the relation amount of work done, which is equals to 1 by 2 m into velocity at a point B bracket square minus velocity. See this, there is a relation between. Here itna relation घेतला पहा. See this, kinetic energy means amount of work done in moving a particle from a point A to B along the curve, means kinetic energy. So we can replace this kinetic energy, we can replace this kinetic energy by work done. इथं आपण kinetic energy घेतलं नाही, kinetic energy नाही घेतलं, work done घेतलं. So work done is equals to 1 by 2. We have proved this relation. Work done is equals to 1 by 2 m into velocity at a point B bracket square minus velocity at a point A bracket square. But velocity at a point B is denoted by VB square minus velocity at a point A is denoted by VA square. But VA is not equals to 0 because it is not a starting velocity. So we can write 1 by 2 m VB square minus, separate this, multiply by 1 by 2 m. So 1 by 2 m VB square minus 1 by 2 m into VA square. So it is called as a 1 by 2 m VB square minus VA square, means kinetic energy at a point B minus kinetic energy at a point A. So work done is equals to change in kinetic energy, and hence proved. See here, note that this is a very important note. What is that? This is known as, see this law, change in kinetic energy of a particle is equal to the work done. इसका मतलब क्या है? This is known as a principle of work and energy. This is known as the principle of work and energy. See this? The change in kinetic energy, change in kinetic energy of the particle is equal to the work done, is equals to work done. This is known as principle of work and energy. प्रिन्सिपल ऑफ वर्क अँड एनर्जी. ओके, तर समजले का रे? हे दोन्ही थेरम तुम्हाला स्टुडंट्स काय अडचण आहे का? फर्स्ट इज थेरम, prove that the kinetic energy of the particle is 1/2 mv square. Second theorem, prove that the change in kinetic energy is equal to the work done of the particle. See this. Okay, काय अडचण आहे का आशुतोष बिराजदार? आशुतोष काय अडचण नाही ना? Okay, now we shall stop here. Now we shall discuss the problems based on this tomorrow. Okay, काय अडचण असेल तर विचारा. चला रे, विचारा, मी तुम्हाला आन्सर देतो.